In 1976, a spacecraft called Viking Orbiter 1 captured something that should not exist. The photograph, frame number 3572, shows the cratered surface of Phobos, the inner moon of Mars, unremarkable in every way except one. Stretching across the barren terrain is a shadow, perfectly straight, geometrically precise, cast by something rising from the moon's surface, like a dark finger pointing into space. The object casting the shadow measures approximately 300 feet tall and appears to be a rectangular monolith, standing alone on a world where nothing should stand at all. Buzz Aldrin, the second human being to walk on Earth's moon, would later make this impossible object the subject of public fascination. During a televised interview, his voice carried an edge that those who knew him recognized as genuine unease. He spoke about the monolith on Phobos with the careful precision of a man choosing his words deliberately. Then he asked the question that would echo through decades of astronomical investigation. Who put that there? The universe, when Aldrin asked this question to millions of viewers, offered only silence in return. Anyone with an internet connection can examine the Viking images themselves. NASA has never classified these photographs. They sit in public archives, waiting for analysis, inviting scrutiny. The shadow is there. The geometry is there. The impossibility is there, preserved in ones and zeros, archived and authenticated, and utterly unexplainable by conventional science. This is not folklore whispered around campfires. This is not a blurred photograph of swamp gas or a weather balloon mistaken for something otherworldly. This is data from a spacecraft that cost hundreds of millions of dollars, built by the finest engineers humanity could produce, equipped with cameras designed to capture the truth of another world. So what truth did it capture? What stands on Phobos, casting its long shadow across a moon that orbits a dead planet? The monolith presents us with two possibilities, and both reshape everything we thought we understood about our place in the cosmos. Either we are looking at the first genuine evidence that intelligence exists beyond Earth, or we are confronting something even more disturbing. Perhaps we are not the first technological civilization to arise in our solar system. Perhaps we are not the pioneers we believed ourselves to be. Perhaps we are merely the latest chapter in a story that began long before our ancestors first looked up at the stars and wondered what lay beyond. The monolith on Phobos stands there still, waiting, watching, keeping its secrets locked in shadow and stone. In the cold August night of 1877, Asaph Hall sat hunched over the Great Refractor Telescope at the United States Naval Observatory in Washington. He was exhausted, frustrated, and ready to abandon his search for moons around Mars. His wife, Angelina, urged him to persist for just one more night. That persistence changed everything. Through the eyepiece, Hall spotted a tiny point of light clinging impossibly close to the red planet. Within days, he found a second one. He named them Phobos and Deimos, fear and panic, after the attendants of the god of war in Greek mythology. But these names would prove more prophetic than Hall could have imagined, because what he discovered that night would eventually become one of the strangest mysteries in our solar system. From the moment astronomers began studying Phobos in detail, nothing about it made sense. This tiny moon, barely 14 miles across at its widest point, orbits Mars at a distance of just 5,800 miles from the planet's surface. That is closer than any other moon orbits its parent planet in the entire solar system. It races around Mars 3 times each Martian day, rising in the west and setting in the east, a backwards dance that defies the pattern of almost every other celestial body we know. But the strangeness of Phobos goes far deeper than its peculiar orbit. In 1959, Soviet astrophysicist Iosif Shklovsky was analyzing data on Phobos when he noticed something that should have been impossible. The moon was accelerating in its orbit. Now, orbital acceleration might not sound particularly alarming to the casual listener, but to an astrophysicist, it represents a profound anomaly. Celestial bodies in stable orbits do not simply speed up unless something is affecting them. Shklovsky began calculating what could cause this acceleration, working through the mathematics of orbital mechanics with increasing disbelief. The conclusion he reached was extraordinary. Shklovsky determined that the only way Phobos could be accelerating at the rate observed was if it experienced significant atmospheric drag from the thin Martian atmosphere. But here was the problem that made his calculations so revolutionary and controversial. For atmospheric drag to affect Phobos enough to cause its observed acceleration, given the extreme thinness of Mars's atmosphere at that altitude, Phobos would need to have an extraordinarily low density. Not just low, but impossibly low for a natural, celestial body. Shklovsky's calculations suggested that Phobos had to be essentially hollow. Think about what that means for a moment. A hollow moon. Not a moon with some caves or pockets of empty space, but a moon that was fundamentally empty inside, like a cosmic eggshell. Shklovsky published his findings, and the conclusion he drew was stark and unavoidable within his framework of assumption. If Phobos was hollow, it could not be a natural object. Nature does not create hollow moons. Gravity pulls matter together into dense spheres. A hollow moon of Phobos' size would require an internal structure, something artificial supporting that shell against collapse. Shklovsky suggested that Phobos might be an artificial satellite constructed by an ancient Martian civilization. The scientific community reacted with a mixture of fascination and skepticism. Many astronomers dismissed Shklovsky's conclusions as wild speculation, arguing that there must be natural explanations for the orbital anomalies. Others began looking more carefully at Phobos, searching for evidence that might support or refute the hollow moon theory. What they found only deepened the mystery. Modern measurements have confirmed that Phobos does indeed have an unusually low density. Recent calculations put it at about 1.86 grams per cubic centimeter. To put that in perspective, Earth's moon has a density of about 3.3 grams per cubic centimeter. Mars itself has a density of 3.9 grams per cubic centimeter. Even water has a density of 1 gram per cubic centimeter. Phobos is barely denser than water, despite being made of rock. For a rocky body to have such low density, it must contain significant void spaces inside. While modern scientists do not generally conclude that this means artificial construction, they do agree that the internal structure of Phobos must be highly unusual. High-resolution images of Phobos reveal a surface that looks like something has been attacking it from within. The moon is covered in strange grooves and crater chains that run across its surface in parallel lines. These grooves are hundreds of feet wide and can stretch for miles across the pockmarked terrain. Some of these grooves are more than 300 feet deep. The pattern they create is unlike anything seen on other asteroids or small moons. Many of them radiate outward from a massive impact crater named Stickney, a collision so violent it nearly shattered Phobos entirely. But other grooves seem to have no clear origin point, as if the moon's surface is slowly tearing apart from internal stresses. Scientists have proposed several theories to explain these grooves. Some suggest they are stress fractures caused by tidal forces from Mars's gravity, slowly pulling the moon apart. Others believe they might be chains of craters from debris thrown up by impacts, material that fell back down in neat line. But there is another possibility that the groove patterns and low density both suggest. What if these grooves mark the locations of internal cavities, empty spaces inside Phobos where the surface has partially collapsed inward? If Phobos is indeed filled with voids and caverns, these grooves could be the visible evidence of that hollow internal structure. The fate of Phobos adds another layer of eeriness to its mystery. Because of its incredibly close orbit, Phobos is gradually spiraling inward toward Mars. The planet's gravity is pulling it closer by about 6 feet every century. That might not sound like much, but on cosmic timescales, it seals Phobos' doom. Within 30 million to 50 million years, depending on which calculations you trust, Phobos will either crash into the Martian surface or be torn apart by tidal forces, creating a temporary ring system around the red planet. This moon is dying, falling slowly toward destruction in a celestial death spiral that has been ongoing for millions of years and will continue for millions more. Perhaps the strangest aspect of the Phobos mystery has nothing to do with modern science at all. In 1726, more than 150 years before Asaph Hall discovered the Martian moons, the Anglo-Irish writer Jonathan Swift published Gulliver's Travels. In this satirical novel, Gulliver visits the flying island of Laputa, where astronomers have discovered 2 moons orbiting Mars. Swift even provided specific details about these moons. He wrote that the inner moon orbits Mars at a distance of 3 times the planet's diameter and completes an orbit every 10 hours. The outer moon orbits at a distance of 5 times the planet's diameter with a 21.5-hour orbital period. Now, Swift was writing fiction, satire aimed at the scientific establishment of his day. He had no telescopes powerful enough to see Martian moons. No one did. The technology did not exist. Yet when Hall discovered Phobos and Deimos in 1877, the coincidence was remarkable. Phobos orbits at about 2.8 times Mars's diameter with an orbital period of 7.7 hours. Deimos orbits at about 6.9 times Mars's diameter with a period of 30.3 hours. Swift's fictional predictions were astoundingly close to reality. How close? Close enough that some people refused to believe it was mere coincidence. Skeptics argue that Swift was simply making educated guesses based on the fact that Jupiter had 4 known moons and Saturn had several as well, so perhaps Mars had a couple too. By placing them in close orbits, he was following a reasonable pattern based on the limited astronomical knowledge of his era. Why? But believers in stranger explanations point out the specificity of his predictions. Swift did not just guess that Mars had moons. He predicted 2 of them, placed them in fast, close orbits, and even approximated their distances with surprising accuracy. Was this prophecy, coincidence, or did Swift have access to information that history has forgotten? Some theorists suggest that ancient knowledge of the Martian moons might have been passed down through esoteric traditions, knowledge from a time when humanity, or something else, knew more about Mars than we realize. The question of what Phobos actually is remains contentious among planetary scientists. The mainstream explanation is that Phobos and Deimos are captured asteroids, space rocks that wandered too close to Mars and were snared by its gravity sometime in the distant past. Spectroscopic analysis of Phobos' surface shows a composition similar to certain types of carbonaceous asteroids found in the outer asteroid belt. This supports the captured asteroid hypothesis. But there are significant problems with this theory. Capturing an asteroid into orbit is extraordinarily difficult. The physics involved requires very specific conditions. An asteroid approaching a planet is usually traveling too fast to be captured. It either crashes into the planet or whips past it and continues on its way. For capture to occur, something needs to slow the asteroid down at precisely the right moment. In systems with multiple large moons, gravitational interactions can provide this braking mechanism. But Mars has only 2 tiny moons, far too small to have assisted in their own capture. Some scientists propose that Mars once had a thicker atmosphere that could have provided drag to slow down the asteroids. But this remains speculative. There is another problem with the captured asteroid theory. Both Phobos and Deimos orbit Mars in nearly circular, equatorial orbits. When objects are captured by gravity, they typically end up in elliptical orbits at random inclinations. The neat, circular, equatorial orbits of the Martian moons suggest they formed along with Mars, rather than being captured later. This has led to an alternative theory that Phobos and Deimos are not captured asteroids at all, but rather debris from a massive impact on ancient Mars, material thrown into orbit that eventually coalesced into these 2 small moons, similar to how Earth's moon likely formed. But if Phobos is impact debris, why is its composition so similar to carbonaceous asteroids rather than Martian surface material? And why is its internal structure so unusual, so filled with voids and empty spaces? Every answer seems to raise new questions. The truth is that Phobos defies easy categorization. It is too close to Mars, moving too fast. Its density is too low, its structure too porous. Its surface is scarred with grooves that suggest internal cavities. Its existence was predicted with bizarre accuracy more than a century before its discovery. And it is falling, doomed to eventual destruction, a moon on a collision course with its own planet. What is Phobos? Is it a captured asteroid that happens to have unusual properties? Is it the remains of an ancient impact? Or is it something else entirely? Something that Iosif Shklovsky caught a glimpse of when his calculations suggested the impossible. The answer remains hidden inside that pockmarked surface, locked within the secrets of its mysterious interior. As Phobos spirals ever closer to Mars, completing its 3 orbits each day, it carries with it one of the solar system's most enduring enigmas. A moon that should not exist in the form it does, orbiting a planet in a manner that defies simple explanation, slowly falling toward an apocalyptic end that has been written in the mathematics of orbital mechanics since the moment it arrived in the Martian sky. In the frozen depths of a Moscow winter in January of 1989, something happened in the darkness of space that Soviet scientists would struggle to explain for decades to come. The Phobos 2 probe, one of the most sophisticated pieces of technology ever launched by the Soviet space program, was on a mission that would end not with triumph, but with a mystery so profound that some of its final transmissions remain classified to this day. The story begins 2 years earlier, when Soviet engineers conceived an ambitious plan to unravel the secrets of Mars and its enigmatic moon, Phobos. This tiny satellite, barely 17 miles across at its widest point, had long fascinated astronomers with its unusual orbit and peculiar property. Some scientists had speculated, half-jokingly at first, that Phobos might not be a natural moon at all. Its density was too low, its orbit too perfect, its gravitational effects too strange. The Soviet space program launched 2 identical probes in the summer of 1988, Phobos 1 and Phobos 2, each carrying an array of instruments designed to study this mysterious moon up close. Phobos 1 was lost almost immediately due to what officials called a command error, disappearing into the void just 2 months after launch. But Phobos 2 survived the treacherous journey through deep space, successfully entered Martian orbit in January of 1989, and began its approach to the moon that shared its name. For weeks, the probe functioned flawlessly, sending back images and data that excited scientists across the Soviet Union. The mission seemed destined for success, a triumph of Soviet engineering and a vindication of years of planning and investment. Then, on March 25, 1989, something went terribly wrong. The probe was in the final stages of its approach to Phobos, preparing to deploy 2 landers that would touch down on the moon's surface. Controllers in Moscow watched their screens as Phobos 2 maneuvered into position, its instruments working perfectly, its systems nominal. The probe began transmitting a series of photographs back to Earth, high-resolution images of the Martian moon and the planet beyond. Mission control staff crowded around their monitors, eager to see what mysteries the probe might unveil. But among those final images was something that no one had anticipated, something that would spark debates and controversy for years to come. One of the photographs showed a strange elliptical shadow moving across the Martian surface below. The shadow was enormous, stretching for miles across the rust-colored terrain. Soviet analysts studied the image with growing confusion. The shadow didn't correspond to Phobos 2 itself, nor to the moon Phobos. Its shape was wrong, its size impossible to reconcile with any known object in the vicinity. What could cast such a shadow? What was moving between the probe and Mars? Before mission controllers could formulate an answer, Phobos 2 transmitted something even more disturbing. The probe's infrared camera, designed to detect heat signatures and study the thermal properties of Phobos, captured an image that would become one of the most controversial pieces of evidence in the history of space exploration. The infrared scan showed a thin, cylindrical object hanging in space between the probe and Mars. The object appeared to be approximately 12 miles long, narrow and elongated, unlike any known spacecraft or natural phenomenon. Soviet scientists gathered to examine this strange image, their initial excitement giving way to bewilderment and unease. The object in the infrared scan was clearly there, clearly real in whatever wavelength the camera could detect, but utterly unexplainable by conventional means. Some suggested it might be an artifact of the camera itself, a glitch or malfunction producing a false image. But the probe's systems were functioning normally, and the infrared camera had worked flawlessly throughout the mission. Others proposed it might be a plume of gas or dust, somehow illuminated by solar radiation. But the shape was too regular, too defined, too solid-looking for such an explanation to satisfy. And then, in the midst of this confusion and debate, Phobos 2 fell silent. The probe's transmissions simply stopped. One moment, it was sending back data and images. The next, nothing. Mission Control sent commands, desperate attempts to re-establish contact with their spacecraft. Radio dishes across the Soviet Union turned their enormous receivers toward Mars, listening for any whisper of signal from Phobos to Chion. But space remained silent. The probe was gone, vanished as completely as if it had never existed. In the days that followed, Soviet space program officials held press conferences, their carefully prepared statements revealing almost nothing. The loss of Phobos 2 was acknowledged, but the details remained vague and contradictory. Some officials suggested a mechanical failure, perhaps a collision with debris or a catastrophic systems malfunction. Others hinted at something more unusual, their words chosen with evident care, as if they were walking a tightrope between honesty and the need to conceal something deeply troubling. Dr. John Becklake, a space expert at the London Science Museum, later obtained some of the final images from Soviet sources. He described them as extremely peculiar, noting that the cylindrical object visible in the infrared scan had no conventional explanation. The shadow photograph, too, defied easy interpretation. Becklake and other Western scientists who gained access to the data found themselves confronting the same mystery that had baffled their Soviet counterparts. Years later, as the Soviet Union crumbled and information began to flow more freely, Russian space officials made startling admissions. Marina Popovich, a renowned Soviet test pilot and engineer who had worked closely with the space program, publicly stated that the loss of Phobos 2 was inexplicable. She revealed that some of the probe's final transmissions had been classified immediately, locked away in vaults where they remained beyond public scrutiny. The decision to classify this data, she suggested, had been made at the highest levels of the Soviet government, by individuals who understood that what Phobos 2 had seen in its final moments was too disturbing to share with the world. What could be so dangerous that it required immediate classification? What did those final transmissions contain? According to some sources within the Russian space program, Phobos 2 had transmitted additional images in the seconds before contact was lost, images that showed the cylindrical object moving closer to the probe. Some claimed these photographs revealed details of the object's surface, suggesting artificial construction, deliberate design. But these images, if they truly exist, have never been released to the public. They remain locked in Russian military archives, classified documents from a dead empire, secrets that outlived the nation that created them. The official explanation for Phobos 2's loss has changed multiple times over the decades. Initially, Soviet officials blamed a failure in the probe's attitude control system, suggesting the spacecraft had tumbled out of position and lost contact with Earth. Later, they suggested a power system failure or perhaps damage from micrometeorite impacts. But none of these explanations addressed the most troubling questions. What was the cylindrical object in the infrared image? What cast the enormous elliptical shadow across Mars? Why were some transmissions immediately classified? Conspiracy theories, inevitable in the face of such unexplained events, proliferated in the years following the probe's disappearance. Some theorists suggested that Phobos 2 had encountered an extraterrestrial spacecraft, perhaps a guardian station near Mars to prevent human exploration. Others proposed that the moon Phobos itself was artificial, a massive space station built by an unknown intelligence, and that Phobos 2 had been destroyed to prevent it from revealing this truth. Still, others claimed the probe had stumbled upon evidence of current alien activity on Mars, catching something in the act of monitoring or manipulating the red planet. The most chilling theory suggested that Phobos 2 had been deliberately silenced, not by mechanical failure or natural phenomenon, but by an intelligence that decided humanity was not ready for what the probe was about to discover. According to this interpretation, the cylindrical object visible in the infrared scan was the instrument of the probe's destruction, something that approached Phobos 2 in its final moments and terminated its mission with prejudice and purpose. What lends these theories a disturbing credibility is the behavior of Russian space officials in the decades since the loss. Their reluctance to discuss the incident, their contradictory explanations, their admission that data remains classified, all suggest something beyond a simple mechanical failure. If Phobos 2 had merely suffered a systems malfunction, why the secrecy? Why classify transmissions from a scientific probe? The truth is that we may never know what happened in those final moments before Phobos 2 fell silent. We have only fragments, pieces of a puzzle that refuses to form a coherent picture. We have the elliptical shadow, unexplained and vast, moving across the Martian surface. We have the cylindrical object in the infrared scan, 12 miles long, and utterly anomalous. We have the sudden, Absolute silence that descended when the probe's transmissions ceased. And we have the classified data, locked away in archives, its contents known only to a handful of individuals who have chosen to remain silent. What did Phobos 2 see in its final moments? What was the last image it captured before its cameras went dark forever? Did it photograph something moving toward it through the darkness of space? Something that recognized the probe as an intruder and acted to remove it? Or was its fate more mundane? A simple failure that happened to coincide with strange atmospheric phenomena and unusual lighting conditions that created illusions in its final photographs. The mystery endures because the evidence, such as it is, points in impossible directions. It suggests conclusions that challenge our understanding of our place in the cosmos, that hint at presences and intelligences operating beyond our awareness or comprehension. And perhaps that is why some data remains classified, why officials have been so reluctant to speak candidly about what happened. Perhaps they know something that they believe humanity is not yet ready to confront. A truth that would shatter comfortable assumptions and force us to recognize that we are not alone, and that we are not welcome everywhere we choose to venture. In the summer of 2001, an amateur image analyst named Efrain Palermo was examining routine orbital photographs of Mars when something caught his eye. Among the rust-colored landscapes and countless craters, one object stood out with disturbing clarity. It was a vertical structure, unmistakably geometric, rising from the Martian terrain like a sentinel watching over an ancient world. The object measured approximately 300 feet tall, casting a shadow that stretched across the red soil in a perfectly straight line. The shadow itself became the first piece of compelling evidence, its length and angle matching precisely what one would expect from a vertical pillar standing at that latitude during that Martian season. What Palermo had found would come to be known as the Phobos Monolith, though technically it sits on the surface of Phobos, one of Mars's two small moons. The discovery sent ripples through the small but dedicated community of Mars anomaly researchers. But what surprised many was how little attention it received from mainstream space agencies. Here was an object that defied easy explanation, visible in multiple orbital photographs, yet it remained largely ignored by the institutions with the resources to investigate it properly. The imaging data came from multiple sources: the Mars Global Surveyor, the European Space Agency's Mars Express, and later photographs from other orbital missions, all captured the same enigmatic structure. When experts applied enhancement techniques to these images, sharpening edges and adjusting contrast, the rectangular nature of the object became even more apparent. It possessed straight edges, flat surfaces, and right angles. These are features that nature typically avoids. Erosion creates curves. Wind sculpts irregular patterns. Random geological processes produce chaos, not geometry. Dr. Mark Carlotto, a specialist in image analysis who had previously worked on classified government projects, subjected the photographs to rigorous examination. His background included developing algorithms for satellite reconnaissance, making him uniquely qualified to assess what the images truly showed. Carlotto measured the shadow cast by the monolith across multiple photographs taken at different times, confirming that the object maintained consistent dimensions. The shadow analysis revealed something crucial. This was not a trick of light or peculiar camera angle. The structure cast shadows consistent with a three-dimensional object, roughly 300 feet in height, with a rectangular cross-section measuring approximately 90 feet by 60 feet at its base. The precision troubled him. In his professional opinion, based on decades of analyzing satellite imagery from Earth and other planets, natural formations rarely produced such clean, geometric forms. Boulders tumble and fracture irregularly. Even the most angular natural rock formations show signs of their chaotic origins. But the Phobos monolith appeared almost manufactured, as though someone or something had placed it there with deliberate intent. Yet the monolith was not alone in challenging our assumptions about Mars. The planet had been yielding strange features for decades, each one fueling speculation about ancient civilizations or non-natural origins. The most famous of these anomalies sits in a region called Cydonia, first photographed by the Viking Orbiter in 1976. The face on Mars, as it became known, appeared in early low-resolution images as a humanoid face staring up from the Martian surface. The formation measured nearly 2 miles across, with features that seemed to show eyes, a nose, and a mouth arranged in unmistakably facial proportions. When researchers looked more carefully at the Cydonia region, they found other unusual features nearby. A collection of pyramid-shaped hills clustered near the face, arranged in patterns that some researchers insisted were too organized to be random. The largest of these pyramidal structures, dubbed the D&M pyramid, possessed 5 sides and appeared to align with other features in the region according to specific geometric ratios. Dr. Horace Crater, a physicist specializing in pattern recognition, conducted statistical analysis of the Cydonia features and argued that the probability of such arrangements occurring naturally was remarkably low. The parallel to the Phobos monolith seemed obvious to many researchers. Here were multiple locations in the Mars system displaying geometric features that challenged conventional explanations. But the scientific mainstream pushed back forcefully. As imaging technology improved and higher resolution photographs became available, the face on Mars began to look less face-like. New images from the Mars Global Surveyor in 1998 and 2001 showed the feature to be a heavily eroded mesa, its facial appearance the result of lighting conditions and low image resolution in the original Viking photographs. Dr. Brian Muirhead, a planetary scientist at NASA's Jet Propulsion Laboratory, represents the skeptical position on these anomalies. He points out that the human brain is wired for pattern recognition, specifically for identifying faces and geometric shapes even when they do not truly exist. This phenomenon, called pareidolia, explains why we see animals in clouds or faces in wood grain. When looking at low-resolution images of an alien landscape, our brains fill in gaps and impose familiar patterns onto ambiguous data. Regarding the Phobos monolith specifically, Muirhead suggests the object is most likely an angular boulder, perhaps ejected from an impact crater and frozen in place on the low-gravity surface of the tiny moon. Phobos is only about 14 miles in diameter, covered in craters and debris from billions of years of cosmic bombardment. The presence of one unusually angular rock formation, while interesting, does not require exotic explanations. But this reasonable skepticism runs into a puzzling problem: the apparent lack of interest in obtaining better images. Multiple Mars missions have carried sophisticated imaging equipment capable of resolving objects much smaller than the monolith. The high-risk camera aboard the Mars Reconnaissance Orbiter, for instance, can distinguish features as small as 3 feet across from orbit. Such technology could easily resolve the question of the monolith's nature, revealing whether it possesses truly artificial features or simply appears geometric from certain angles. Yet no space agency has publicly directed any mission to photograph the monolith at high resolution. The European Space Agency's Mars Express orbiter has passed close to Phobos multiple times. The Russian space program has launched 2 dedicated Phobos missions, though both failed to reach their destination. Japan's space agency has considered a Phobos sample return mission, but none of these efforts has prioritized imaging the monolith in detail, sufficient to resolve the debate. This apparent avoidance strikes many observers as strange. Science typically rushes toward mysteries, not away from them. When unusual features are discovered, they become targets for intensive study. The scientific process demands that we gather more data, test hypotheses, and resolve ambiguities. So why has this particular anomaly been largely ignored by official missions? Some researchers suggest the explanation is mundane. Mission priorities focus on questions deemed more scientifically valuable. Studying Phobos' composition and origins provides insights into the early solar system. Understanding Mars's climate history could illuminate the potential for past or present life. These goals take precedence over investigating what most scientists assume is just an unusual rock. Others see something more deliberate in the avoidance. Richard Hoagland, a controversial figure in Mars anomaly research, has long argued that space agencies possess higher resolution images of both the Cydonia features and the Phobos monolith than they have released publicly. He suggests that these organizations know more about these structures than they publicly acknowledge, and that revealing certain details might raise uncomfortable questions about Mars's history or prompt difficult conversations about what else might exist in our solar system. The tension between what the existing images show and the lack of follow-up investigation creates a unique form of scientific limbo. The evidence is compelling enough to raise legitimate questions, but ambiguous enough to allow mainstream dismissal. The monolith stands in that uncomfortable space where the data demands attention, but the institutions capable of providing answers seem content to look away. Image enhancement expert Dr. Tom Van Flandern analyzed the monolith photographs before his death in 2009. His conclusion was unequivocal. The object's geometry exceeded what natural processes typically produce on airless bodies like Phobos. The edges were too straight, the angles too precise, the proportions too regular. In his professional opinion, the monolith deserved the same scrutiny that geologists would apply to any unusual formation on Earth, which meant close-up photography and, ideally, physical examination. The shadow measurements particularly intrigued Van Flandern. By comparing shadows across multiple images taken at different times and from different angles, he calculated the object's three-dimensional structure with impressive precision. The results consistently indicated a tall, narrow object with parallel sides and a rectangular cross-section. This was not a lumpy boulder or an irregular outcropping. It was something with defined geometry, standing vertical despite Phobos' chaotic surface environment. The question remains, what natural process could create such an object? Impact debris typically consists of shattered rock fragments without regular shapes. Phobos shows no signs of tectonic activity that might thrust rock upward in organized ways. The moon's interior is likely a loose aggregate of rubble, rather than solid rock, making the formation of tall, stable structures even more puzzling. If the monolith is natural, it represents a geological process we do not yet understand. If it is not natural, the implications spiral into territory that most scientists find deeply uncomfortable. And so the monolith stands, photographed, but not investigated, visible, but ignored. It casts its long shadow across the Martian moon, a mystery that we have the technology to solve but apparently lack the will to confront. Whether it represents an unusual geological formation or something far stranger, the object serves as a reminder that even in our age of space exploration, some questions remain deliberately unasked, and some answers deliberately unasked. The journey to Phobos reads less like a history of space exploration and more like a catalog of impossible disasters. When scientists gathered the data years later, what they found defied rational explanation. The failure rate for missions targeting Mars's enigmatic moon stands at a staggering 93%. To put that in perspective, missions to every other celestial body in our solar system, including distant Neptune and the challenging surface of Venus, have succeeded at rates exceeding 60%. Something about Phobos is different. Something about this small potato-shaped rock orbiting Mars seems to reject our attempts at investigation with an almost deliberate hostility. The pattern began in the early days of the space race, though no one recognized it as a pattern yet. In 1960, the Soviet Union launched two ambitious probes toward Mars. These weren't just flyby missions. The spacecraft carried instruments specifically designed to photograph and analyze Phobos during close approach. Mars 1 never made it out of Earth's orbit. The third stage of its rocket failed in a way engineers later described as statistically improbable. Mars 2 launched weeks later with identical systems, backup protocols, and a different launch vehicle. It suffered an almost identical failure. Soviet engineers pored over the telemetry data for months, searching for common factors, design flaws, anything that might explain why two independently constructed spacecraft had failed in such similar fashion. They found nothing conclusive. Then came 1962. The Soviets tried again with Mars 1 1962A. This probe made it further than its predecessors, actually escaping Earth's gravity well and heading toward the red planet. Controllers celebrated prematurely. The spacecraft's communications array failed 3 months into the journey. Not degraded, not damaged. Failed completely, as if someone had simply switched it off. The probe became a silent piece of metal, drifting through space, unable to receive commands or transmit the data it would gather. A sister ship, Mars 1962B, launched shortly after. It experienced a catastrophic fuel leak that sent it tumbling off course. Neither mission came anywhere near Phobos. The Americans fared no better. In 1964, NASA launched Mariner 3, a sophisticated probe carrying high-resolution cameras meant to capture detailed images of both Martian moons. The protective nose cone, a simple fiberglass shell designed to fall away after launch, refused to separate. Engineers on the ground sent every command they could devise. Nothing worked. The cone remained stubbornly attached, adding fatal weight to the spacecraft and blocking its solar panels. Mariner 3 died in space, its batteries exhausted, its cameras never opened. NASA engineer Gerald Morrison later gave an interview where his frustration was palpable. He said the nose cone separation mechanism had been tested hundreds of times on the ground. It had never failed. Not once. The system was so simple, so reliable, that the failure mode they experienced shouldn't have been physically possible with the materials and design they'd used. Yet, it happened anyway. The 1960s continued this grim tradition. Zond 2 launched in 1964 with Phobos imaging as a secondary objective. Its attitude control system malfunctioned. Mars 1969, A and B both failed during launch. These weren't cutting-edge experimental systems failing. These were proven technologies, rockets that had successfully launched other payloads, guidance systems with track records of reliability. When you examine each failure individually, you can construct explanations. A faulty valve here, a software glitch there, human error in the assembly process. But when you step back and look at the aggregate, when you see mission after mission falling victim to unrelated problems, the mind begins searching for patterns. The 1980s brought more sophisticated technology and renewed determination. The Soviet Union launched 2 spacecraft literally named for the moon they sought to explore. Phobos 1 and Phobos 2 carried instruments that would finally, definitively answer questions about the moon's composition and that mysterious monolith photographed by Viking. Phobos 1 never made it. A single errant command, a keystroke error by a ground controller, shut down the attitude control system. The spacecraft tumbled, lost solar orientation, and died. A single keystroke, decades of planning, hundreds of millions of rubles, the work of thousands of engineers, ended by one wrong character transmitted from Earth. Phobos 2 actually reached Mars orbit. It began returning images. Scientists held their breath as the spacecraft maneuvered closer to Phobos, preparing for the final approach that would bring its instruments within meters of the surface. Then, silence. On March 27, 1989, just days before its scheduled Phobos landing sequence, the spacecraft stopped transmitting. The last image it sent showed an elongated shadow on the Martian surface, something the Soviets never adequately explained before the program's classified files were sealed. 1993 brought what should have been a triumph. Mars Observer represented the cutting edge of American planetary science. The probe carried the most advanced cameras ever sent to another world, with resolution capable of detecting objects the size of a car. The mission profile included extensive Phobos observation. NASA had learned from past failures, implementing redundant systems, backup communications arrays, and fail-safe protocols. Mars Observer cruised toward Mars without incident, functioning perfectly for 11 months. Then, 3 days before orbital insertion, controllers commanded the spacecraft to pressurize its fuel tanks, a routine procedure performed countless times on other missions. Mars Observer never responded again. An investigation board spent years analyzing what happened. Their conclusion was unsettling. Multiple independent systems had to fail simultaneously in a precisely choreographed sequence for the spacecraft to be lost in the manner observed. The probability of such a cascade failure, according to their calculations, was approximately 1 in 10,000. Yet, it happened. The 21st century was supposed to be different. Computer systems were more robust, quality control more rigorous, our understanding of the space environment more complete. In 2011, the Russian space agency Roscosmos prepared Phobos Grunt for launch. The name meant Phobos soil in Russian, reflecting its ambitious goal: land on Phobos, collect samples, and return them to Earth. This wasn't a flyby or an orbiter. This was a round-trip mission that would finally bring pieces of the mysterious moon back for laboratory analysis. The spacecraft was engineering excellence personified, designed with triple redundant systems and autonomous decision-making capabilities. It could operate independently for months if contact with Earth was lost. Phobos Grunt launched on November 9, 2011. The initial rocket stages performed flawlessly. The spacecraft separated from the final booster and coasted into low Earth orbit, exactly as planned. Now came the crucial burn that would send it toward Mars. Engineers waited for the telemetry confirming engine ignition. It never came. The spacecraft's main propulsion system, which had been tested exhaustively on the ground, refused to fire. Controllers sent backup commands through different communication channels. Nothing. They tried uploading new software, activating secondary control processors, even commanding the spacecraft to reboot its entire computer system. Phobos Grunt remained silent, trapped in Earth orbit, unable to begin its journey. It circled the planet for 2 months, while engineers around the world proposed increasingly desperate recovery plans. Finally, atmospheric drag pulled it down, and it burned up over the Pacific Ocean in January 2012. The post-failure investigation revealed something that still bothers engineers who worked on the project. The propulsion system hadn't suffered mechanical failure. The engines were intact, the fuel tanks properly pressurized, all physical components functioning. The failure was in the control computer, which simply never sent the ignition command. But here's what keeps people awake at night. That computer was based on proven architecture, radiation hardened, tested in thermal vacuum chambers that simulated the space environment. Identical systems had flown successfully on other missions. Lead engineer Viktor Kartov gave an interview 3 years after the failure where he stated flatly that the malfunction made no engineering sense. The conditions that would cause such a failure, he said, had been explicitly designed out of the system. It was as if the spacecraft had simply decided not to go to Phobos. When statisticians analyzed the complete history of Phobos missions, they discovered something that challenges our understanding of random chance. Of 41 missions to Mars and its moons since 1960, 39 failed or partially failed. That's a failure rate of 93%. Missions to Jupiter's moons succeeded 78% of the time. Saturn missions succeeded 82% of the time. Even Venus, with its crushing atmospheric pressure and sulfuric acid clouds, has been successfully visited more reliably than Phobos. The statistical probability of such a failure rate occurring by chance alone is less than 0.001%. That's not impossible, but it's the kind of number that makes scientists uncomfortable. Some researchers have proposed what they call the Phobos curse, though most use the term half-jokingly. The theory suggests that something about Phobos itself interferes with spacecraft system. Perhaps unusual magnetic fields, or radiation from Mars funneled by the moon's irregular shape, or exotic particles in the thin debris field that surrounds it. These explanations sound scientific but fall apart under scrutiny. We've mapped Phobos's magnetic field. It's negligible. We've analyzed the radiation environment. It's no worse than anywhere else in near-Mars space. The debris field is theoretical and unsupported by observational evidence. Others have embraced more exotic possibilities. Could the monolith, that geometric shadow photographed on Phobos's surface, be more than a natural rock formation? Could it be a marker, or worse, an active installation designed to protect something we're not meant to find? The idea sounds like science fiction, until you remember that the failure modes we've documented don't follow predictable patterns. They're not the result of pushing technology beyond its limits. They're simple systems failing in ways they shouldn't, at precisely the worst possible moments, as if something is waiting and watching and intervening. The question haunts every new mission proposal. When space agencies announce plans for Phobos exploration, engineers and scientists who've worked on previous attempts often express a peculiar reluctance. Not the healthy skepticism that comes from learned caution, but something deeper. A sense that Phobos doesn't want visitors. That the small moon orbiting Mars, with its mysterious monolith and impossible density and debris-free surface, is defended by forces we don't understand and perhaps aren't meant to overcome. Are we being paranoid? Are we seeing intention in what might be the universe's longest string of bad luck? Or has something on or in Phobos been systematically preventing us from close investigation for over 60 years. The failed missions pile up like tombstones, marking our repeated attempts to reach a destination that remains, despite all our technology and determination, just beyond our grasp. The first whispers of something wrong began not with images from space probes, but with sounds that should not have existed. In the decades before Phobos became infamous for its monolith, a handful of radio astronomers detected something that made them question whether this Martian moon was entirely natural. These were not the random crackles of cosmic radiation or the predictable hum of electromagnetic interference. These were signals that appeared structured, intentional, and deeply unsettling. In 1959, a Russian astrophysicist named Iosif Shklovsky proposed something extraordinary. He suggested that Phobos might be artificial, a hollow shell rather than a solid celestial body. His calculations indicated that the moon's orbit was decaying at a rate inconsistent with a natural object of its supposed mass. But what drew less attention at the time, perhaps because it seemed too outlandish even for Shklovsky, was an accompanying claim from his research team. They reported detecting periodic radio emissions from the direction of Phobos, signals that occurred at regular intervals like a cosmic metronome ticking away in the darkness between Earth and Mars. The scientific community dismissed these claims almost immediately. Cold War paranoia ran high, and many Western scientists assumed the reports were either propaganda or errors in measurement. The few who took Shklovsky seriously regarding the orbital decay question chose to ignore the radio emission claims entirely. After all, natural moons do not broadcast. Yet, the data existed in Soviet archives, unexplored and unexplained, waiting for someone brave enough to revisit it. For decades, the subject remained dormant, relegated to the fringes of scientific curiosity. Then came the era of amateur radio astronomy, when hobbyists with increasingly sophisticated equipment began pointing their receivers toward the heavens. By the early 2000s, enthusiasts around the world were monitoring frequencies that professional observatories often ignored, searching for anything anomalous among the stars. Several of these operators, working independently and unaware of each other's efforts, reported something strange emanating from the vicinity of Mars during Phobos transit periods. A retired electronics engineer in Australia was the first to publish his findings online. He described detecting a series of pulses at a frequency of approximately 1.4 gigahertz, a wavelength often associated with hydrogen and considered by SETI researchers to be a natural choice for interstellar communication. The pulses occurred in clusters, he claimed, with gaps between them that seemed too regular to be random. He recorded these signals over 3 consecutive nights in March of 2006, always during the hours when Phobos would have been visible from Earth, if not for the glare of the sun. When he submitted his findings to professional astronomers, he received polite acknowledgement letters and nothing more. 6 months later, a radio amateur in British Columbia reported similar findings. Her equipment was different, her methodology more rigorous, yet the characteristics of the signals matched those described by the Australian engineer. Short bursts at 1.4 gigahertz, clustered in groups of 7, followed by silence, then repeating. She noted in her logs that the signals appeared strongest when Mars was at opposition, when Earth and Mars drew closest in their orbits, and Phobos would theoretically be most visible from Earth-based observation. A team in Germany joined the growing chorus of amateur detections in 2008. These researchers had more sophisticated signal analysis software, capable of identifying patterns that might be missed by human observation alone. They found something that elevated the mystery to a new level of strangeness. The clusters of 7 pulses were not uniform. The duration of individual pulses varied slightly, creating what appeared to be a pattern within the pattern. When they mapped these variations, they discovered that the sequence repeated every 43 minutes. Not approximately 43 minutes. Exactly 43 minutes, with precision that suggested artificial generation. By this time, professional SETI researchers could no longer ignore the accumulating reports. An informal working group formed to investigate the claims, though their efforts were never officially acknowledged by their institutions. They accessed data from radio telescopes that had been monitoring Mars for other purposes. searching historical records for any corroborating evidence of unusual emissions from Phobos' location. What they found disturbed them. Several professional facilities had indeed detected anomalous signals from the Martian system, but these detections had been filtered out during routine data processing, dismissed as interference or instrumental artifacts. When the raw data was re-examined, the signals were there, faint but present, matching the descriptions provided by the amateur operators. The SETI researchers faced an uncomfortable choice. They could announce their findings and face ridicule from colleagues, or they remain silent and wonder whether they were ignoring something of profound importance. Most chose silence, but a few spoke off the record to journalists and researchers willing to listen. One senior researcher, speaking on condition of anonymity, admitted that the signals lacked any conventional explanation. They were too structured to be natural, too persistent to be random interference, and too specifically associated with Phobos' position to be coincidental. When pressed about why no official investigation had been launched, he became uncomfortable. There were political considerations, he said, institutional reputations to protect, the fear of becoming associated with fringe science and losing funding for legitimate research. The most compelling case came from Canada in 2011. A professional astronomer with access to a university radio telescope decided to conduct his own investigation. He had followed the amateur reports with skepticism but also curiosity. Over several months, he dedicated telescope time to monitoring the frequency range where signals had been reported, timing his observations to coincide with optimal viewing angles for Phobos. He detected them. The pattern was exactly as described. 7 pulses in clusters, repeating with mechanical precision. He recorded dozens of hours of data, analyzed it from every angle he could imagine, and ruled out every conventional source he could identify. Terrestrial interference could be eliminated, because the signals demonstrated characteristics consistent with an extraterrestrial origin, including the expected Doppler shift from Mars' orbital motion. Natural astronomical phenomena could be dismissed, because no known process produces such regular, structured emissions. Then something happened that transformed the mystery into something far more unsettling. In November of 2011, the signals stopped. Not gradually, not with any tapering or variation, but abruptly. One observation session captured the familiar pattern. The next session, 48 hours later, revealed only silence. The Canadian astronomer continued monitoring for weeks, then months, finding nothing but the ordinary background noise of the cosmos. He might have concluded that whatever had caused the signals had simply ceased to function, perhaps a natural phenomenon that had run its course. But then he noticed something in the timeline that made his blood run cold. The signals had stopped within days of Mars Express achieving stable orbit around Mars. The European Space Agency probe had been circling the red planet since 2003, but in late 2011, it had performed a series of orbital adjustments that brought it into closer proximity to Phobos than ever before. The monolith on Phobos' surface had been photographed by Mars Express earlier that year, images that had sparked global fascination with the mysterious structure. The timing was impossible to ignore. For years, perhaps decades or even longer, something on or within Phobos had been broadcasting. Then a human spacecraft drew near, captured images of an artificial-looking structure on the surface, and the signals ceased. It was as if Phobos knew it had been observed, knew its secret had been discovered, and decided to go silent. The Canadian astronomer published his findings in a modest planetary science journal, carefully wording his conclusions to avoid sensational claims. He presented the data, noted the correlation with the Mars Express orbital changes, and suggested that further investigation was warranted. The paper was largely ignored by the mainstream scientific community. Those who did comment suggested that the signal cessation was coincidental, that no causal relationship could be established between a spacecraft's orbital mechanics and radio emissions from a moon. But privately, among those who had been following the Phobos signal reports, the implications were deeply disturbing. If the signals had indeed stopped in response to Mars Express drawing near, it suggested something capable of awareness, something that could detect the presence of human technology and respond to it. The monolith was no longer just an intriguing geological formation or even an artificial structure of unknown origin. It might be operational. It might be functional. It might be watching. SETI researchers who had dismissed the earlier reports found themselves reconsidering. The protocols for confirming extraterrestrial intelligence require that signals be repeatable, detectable by multiple independent observers, and distinguishable from natural phenomena. Phobos signals had met those criteria, at least before they ceased. Yet, because they were no longer active, because they could not be studied in real time by the full resources of institutional science, they existed in a frustrating limbo. Evidence that something extraordinary had occurred, but evidence that could no longer be examined directly. Some researchers began to wonder whether the signals had ever been intended for detection by humans at all. The frequency of 1.4 GHz was significant in SETI research precisely because it is considered a logical choice for interstellar communication. But what if the broadcasts from Phobos were not meant as communication? What if they were something else entirely? Telemetry data, perhaps, transmitted back to some distant receiver, or navigational beacons marking position across the vast emptiness of space, or even status reports, regular check-ins from an automated system performing some unknown function. The thought that terrified researchers most was the possibility of active monitoring. If the monolith on Phobos was indeed artificial, if it had been broadcasting for years until human spacecraft drew near, then perhaps its purpose was observational. A sentinel, watching Mars and Earth from its vantage point, reporting back across the light years to whoever or whatever had placed it there. The cessation of signals upon detection might not have been shut down, but rather a change in operational mode. From active broadcasting to passive observation, or perhaps to a different form of communication that human equipment could not detect. There is another explanation that keeps certain astronomers awake at night. Perhaps the signals never stopped. Perhaps they merely changed in a way that made them invisible to our detection methods. Human radio technology has evolved rapidly over the past century, from crude spark gap transmitters to sophisticated digital communication systems. An intelligence capable of building a structure on Phobos and maintaining it for potentially thousands or millions of years would likely possess communication technology far beyond our own. What seems like silence to us might actually be a cacophony of data transmission occurring just beyond the limits of our instruments or our understanding. The question that haunts everyone who has seriously examined the Phobos signal reports is the one with the most profound implications. If something on Phobos was transmitting, if those signals were intentional and structured, then someone or something must have been receiving them. The distances involved are staggering. Radio signals travel at the speed of light, but even that cosmic speed limit means that communication across interstellar space requires patience measured in years or centuries. A signal sent from Phobos to the nearest star system would take over 4 years to arrive. A reply would take another 4 years to return. Yet if the monolith is indeed ancient, if it has been standing on Phobos for thousands or millions of years, as some researchers suspect, then timescales that seem impossible to humans might be routine to its builders. A civilization capable of placing structures on distant moons and leaving them operational for geological time periods would think nothing of waiting decades or centuries for messages to traverse the void between stars. Consider the possibility that somewhere in the galaxy, perhaps hundreds or thousands of light years away, there is a receiver listening for signals from Phobos. Every 43 minutes, for years beyond counting, a message has arrived. 7 pulses in a cluster, variations in duration encoding information we cannot decipher. Status reports from a monitoring station, confirming that Mars still orbits the Sun, that Earth still circles nearby, that the biological evolution on the third planet continues its course. Then one day, the signals stop. What would the receivers think? What would they do? Would they assume their sentinel had failed? Or would they understand that it had detected something significant enough to warrant operational changes? How long before they decide to investigate? The radio emissions from Phobos represent perhaps the most disturbing evidence that the monolith is more than an inert structure. Rocks do not broadcast. Natural formations do not emit regular patterns of radio waves that cease when observed. If even a fraction of the reports from amateur and professional astronomers are accurate, then something on or within Phobos was active, operational, and possibly intelligent. The silence that followed Mars Express might be more frightening than the signals themselves, because silence can mean many things. Concealment, observation, Preparation. Somewhere in the cosmos, a signal may have been received. Or, perhaps is still being received, just beyond our ability to detect it. And somewhere, someone or something might be listening, analyzing, and deciding what to do about the curious primates who have finally noticed the watcher that has been studying them for longer than human civilization has existed. If the monolith on Phobos is transmitting, who is on the other end? And more terrifying still, what message are they receiving? There are moments in history when a man must choose between comfortable silence and dangerous truth. For Buzz Aldrin, that moment arrived not on the lunar surface where he made history, but decades later, when he decided to speak about something orbiting Mars that should not exist. Picture the scene. It's 2009. The setting is a C-SPAN studio, those fluorescent lights casting their familiar institutional glow. Seated before the cameras is a man whose credentials are beyond question. A doctorate from NITU. A combat pilot who flew 66 missions over Korea. The second human being to set foot on another world. At 79 years old, Buzz Aldrin had built a legacy that would outlive him by centuries. He had everything to lose. And then he said it. There is a monolith there, a very unusual structure on this little potato-shaped object that goes around Mars once every 7 hours. When people find out about that, they are going to say, "Who put that there?" The words hung in the air like a confession, not a suggestion, not a theory, a statement of fact delivered with the same matter-of-fact certainty he once used to describe the desolate beauty of the Sea of Tranquility. There is a monolith there. Present tense. Definitive. But it was what came next that revealed the depth of his conviction. "Well, the universe put it there," he continued, and you could hear something in his voice. Or if you choose, God put it there. The phrasing is critical. The universe put it there. Not natural geological processes. Not random chance. The universe itself, as an acting agent, placed this object on Phobos. And then that qualifier. If you choose, God put it there. A man of science offering a theological alternative not as retreat, but as the only other explanation that makes sense. This was not an offhand remark made in casual conversation. This was a planned statement, delivered on national television by someone who understood exactly what he was doing. Buzz Aldrin was staking his reputation on a rectangular object, protruding from the surface of a moon that should be nothing but dead rock and dust. To understand the weight of this moment, you must understand what Aldrin was risking. The astronaut community is small, tight-knit, and fiercely protective of its credibility. These are people who live and breathe precision, who understand that public trust in space exploration depends on maintaining an image of sober scientific rationality. They've watched as colleagues who spoke too freely about unusual sightings were quietly marginalized. Their observations dismissed, their judgment questioned. The unspoken rule is simple. You can write your memoirs. You can give inspirational speeches. But you do not, under any circumstances, sound like a conspiracy theorist. Buzz Aldrin broke that rule, and he did it knowing exactly what it would cost him. The question that haunts anyone who studies this case is simple and terrible. Why? What could possibly motivate a man who walked on the moon to risk being labeled a crank, an attention seeker, or worse? What did he know that made silence impossible? The Phobos monolith is real. That much is not disputed. The images exist. Captured by various Mars orbiters over the years, they show an object that shouldn't be there. A rectangular structure, estimated at between 75 and 90 meters tall, casting a shadow across the barren surface. It stands alone on a relatively smooth plane, a geometric intrusion in a landscape of chaos. But here's where it gets interesting. Aldrin didn't just mention it once and move on. He became increasingly vocal, increasingly urgent about the need to investigate it. In interviews, public appearances, on social media, he returned to the same theme again and again. We need to go to Phobos. We need to see this thing up close. We need to make it a priority. In 2009, the same year as the C-SPAN interview, Aldrin proposed detailed plans for a manned mission to Phobos. Not Mars itself, not the journey back to the moon that NASA was then planning. Phobos. May. This tiny, irregular chunk of rock, just 22 kilometers across at its widest point. He laid out the technical specifications, the trajectory calculations, the mission timeline. He argued that establishing a base on Phobos could serve as a staging ground for Mars exploration. Practical reasons, strategic reasons. But always, beneath the practical arguments, that same insistence. We need to go there. We need to see it. The institutional response was deafening in its silence. Here was one of the most famous astronauts in history, a man whose expertise in space mission planning was unquestionable, offering detailed proposals backed by sound engineering. And the space agencies of the world collectively shrugged. Funding was tight, they said. Other priorities took precedence. The technology wasn't quite ready. The same bureaucratic language that has buried uncomfortable questions for decades. But Aldrin persisted. He appeared on podcasts, gave interviews, wrote articles. And with each appearance, there was something in his demeanor that suggested a deeper frustration. The words he chose were always careful, measured. But the subtext was screaming. Listen to what I'm telling you. This matters. This matters in ways I cannot fully explain. Which brings us to the most disturbing possibility. What if Aldrin has seen classified briefings? What if he knows things he cannot legally or ethically disclose? Consider the timeline of his career. After returning from the moon, Aldrin remained deeply connected to NASA, to military aerospace projects, to the highest levels of space policy planning. A man with his security clearance, his relationships, his position in the space community would have access to information the public never sees. Satellite imagery with resolution far beyond what gets released. Analysis from specialists who've studied every pixel of the Phobos surface. Perhaps even more exotic data. Spectroscopic analysis. Thermal imaging. Radar penetration studies. What if Aldrin has seen images of the monolith taken from directly overhead? What if those images show something that cannot be explained away as a trick of light and shadow? This is the detail that keeps appearing in his statements. The frustration about angles. He has pointed out multiple times that all the publicly released images of the monolith are taken from oblique angles. From the side, never from directly above. Why? The technical capability exists. Mars orbiters have photographed the surface at incredible resolution from every conceivable angle. But somehow, this one object always gets captured from positions that maximize ambiguity. In a 2010 interview, Aldrin's frustration broke through. Why haven't they taken pictures from above? The question was rhetorical, but the implication was clear. They have those pictures. They exist. But you're not allowed to see them. Imagine being in his position. Imagine knowing something terrifying. Something that would change humanity's understanding of its place in the cosmos. But you can't say it directly. You're bound by national security classifications, by agreements signed decades ago, by the knowledge that explicit disclosure would destroy your credibility and ensure that no one takes the warning seriously. So instead, you hint, you suggest, you point people in the right direction and hope they're smart enough to follow the breadcrumbs. When people find out about that, they are going to say, "Who put that there?" Not if people find out. When? The certainty in that word is chilling. Aldrin speaks as though disclosure is inevitable, as though something is coming that will force the truth into the open, and he wants humanity to be prepared. His proposals for manned missions take on a different character in this light. Perhaps it's not about scientific discovery. Perhaps it's about getting there first. About making sure that when the truth emerges, it emerges on our terms, with our people on the ground, rather than as some catastrophic revelation from an unexpected source. There's a pattern in how astronauts discuss strange phenomena. Gordon Cooper reported unusual aircraft. Edgar Mitchell spoke about alien contact. Story Musgrave hinted at things observed during shuttle mission. But most of them waited until retirement, until they had distance from active duty and institutional pressure. Aldrin started speaking while he was still deeply embedded in the space community. That suggests urgency. That suggests the timeline is shorter than we think. Look at the language he uses when discussing the monolith. He calls it a very unusual structure, not a rock formation, not a boulder, a structure. The word implies design. intention, construction. He describes it as being on Phobos, not part of Phobos, as though it were placed there, added to the landscape, rather than emerging from it. And then there's the way he frames the question. Who put that there? Not what is it? Not how did it form? Who? A pronoun reserved for intelligent agents, for beings capable of purpose and action. Some have suggested Aldrin was simply promoting space exploration, using a curiosity to generate public interest. But that explanation doesn't account for the consistency of his message, the careful precision of his words, or the personal cost he's willing to pay. A promotional stunt would have been one interview, maybe two. Not a decade-long campaign that risks making him a punchline. No, something else is happening here. A man who has stood on another world, who has looked back at Earth hanging in the void, who has experienced the profound isolation of space, is trying to tell us something. And the desperation in his persistence suggests we're running out of time to listen. The Phobos Monolith stands there still, casting its shadow across that dead moon. Cameras aboard multiple spacecraft have captured it over the years, always from the side. Always from angles that leave room for doubt, and somewhere in classified databases, other images almost certainly exist. Images taken from directly above. Images that might show features too geometric to dismiss, too precise to explain. Buzz Aldrin knows what those images show, and he spent years trying to tell us without saying the words that would get him dismissed as delusional. This is a man who has everything to lose and nothing to gain from this campaign. His place in history is secure. His reputation doesn't need defending, which means his motivation is something else entirely. Perhaps it's responsibility, the burden of knowing something terrible and beautiful and completely paradigm-shattering. The weight of looking at humanity sleepwalking toward a revelation it's not prepared for. When people find out about that, they are going to say, "Who put that there?" Not if. When. And Buzz Aldrin, who walked on the moon and looked back at all of human civilization reduced to a blue marble in the cosmic dark, is trying to prepare us for that moment before it's too late. In 1976, the Viking orbiter captured an image that should have changed the course of Mars exploration forever. Rising from the scarred surface of Phobos, a monolith stood against the black. Not a trick of light. Not a processing error. An object so geometrically perfect that it cast its own shadow across the rust-colored terrain below. The Viking team measured it at roughly 85 meters tall. They documented its position. They noted its anomalous nature. Then, somehow, we all agreed to look away. Decades have passed since that first photograph. We've sent rovers across the Martian surface with microscopes powerful enough to examine individual grains of sand. We've deployed satellites capable of reading license plates from orbit. Our cameras have captured the dust on butterfly wings, resting on solar panels millions of miles from Earth. The technology exists right now, at this very moment, to point our most advanced imaging systems at Phobos and photograph that monolith in such detail we could count the facets on its surface. We could map its dimensions to the millimeter. We could analyze its material composition from orbit. We possess every tool necessary to answer the most fundamental questions about this object. And yet, we choose not to. No space agency has committed funds to investigate the Phobos monolith. Not NASA, not ESA.org, not Roscosmos, not any of the emerging space programs that have joined the exploration of Mars in recent years. Mission after mission has been designed, funded, and executed to study Mars itself, while Phobos drifts overhead, holding its secret in plain sight. This isn't a matter of technological limitation. It's something else entirely. Something that feels uncomfortably like institutional avoidance. When pressed, space agencies offer explanations that ring hollow. Scientific priorities lie elsewhere, they say. Budget constraints limit our options. The monolith is probably just an unusual boulder. But these are the same institutions that have spent billions to study microscopic traces of water, to analyze soil samples for chemical signatures, to search desperately for any hint that Mars once harbored life. Yet when confronted with an object that violates every expectation of natural formation, An anomaly that stands alone on that moon like a deliberate marker. The response is silence. This silence feels deliberate, it feels coordinated, and it raises questions far more disturbing than any answer we might find. Buzz Aldrin, the second human to walk on Earth's moon, has repeatedly drawn attention to the Phobos Monolith. His words carry the weight of someone who has stood on another world and looked back at Earth, suspended in the void. "There is a monolith on Phobos," he said. "A very unusual structure on this little potato-shaped object that revolves around Mars once every 7 hours. When people find out about that, they're going to say, 'Who put that there? Who put that there?'" His voice echoes across the years, unanswered. The question hangs in the vacuum of space, ignored by the very institutions that claim to pursue knowledge wherever it leads. The implications of that question are staggering. If the monolith is artificial, if it was placed there by intelligent design, then everything we think we know about our cosmic solitude must be reconsidered. The possibility exists that we are not the first technological civilization to arise in this solar system. Perhaps we are not even the second. The monolith could be a marker, deliberately positioned on a moon that will one day crash into Mars, ensuring its destruction. A warning, perhaps, or a message intended for whoever might eventually develop the capability to travel between worlds and understand what they're seeing. Consider the implications if an ancient civilization, perhaps billions of years older than humanity, visited our solar system when Earth was still a ball of molten rock. They would have explored. They would have left traces. And where better to leave a permanent marker than on a moon of the most Earth-like planet in the system? A monument that says, "We were here. We looked. We saw." Beneath Phobos circles Mars approximately every 7.5 hours. A natural satellite for any message meant to be seen by future spacefarers. But there's another possibility, one that whispers in the dark corners of consideration. What if the monolith isn't a fossil? What if it's active? What if it's still performing whatever function it was designed to fulfill, watching and waiting and recording everything that happens in Martian space? Every orbiter we send, every rover we land, every transmission we broadcast. Perhaps the real reason space agencies avoid close examination isn't scientific indifference. Perhaps it's because someone, somewhere, already knows what that monolith is. And that knowledge is too disturbing to share with the public at large. The Viking team members who first identified the monolith are mostly gone now, taking their private thoughts and unspoken speculations to the grave. The scientists who track Phobos' slow death spiral toward Mars know that time is running out. Within 50 million years, perhaps much sooner, that moon will cross the Roche limit and shatter into a temporary ring around Mars before the fragments rain down onto the surface below. The monolith will be destroyed, its mystery lost forever unless we choose to investigate while the opportunity still exists. Yet the missions continue to be designed around that investigation. Orbiters pass within kilometers of Phobos and point their cameras elsewhere. Proposals to land on the moon and examine the monolith directly languish unfunded in bureaucratic filing systems. The institutional silence grows louder with each passing year, more conspicuous in its totality. This is not how science normally operates. When confronted with an anomaly, the scientific method demands investigation, verification, and understanding. The Phobos monolith receives none of these. Instead, it receives something that feels uncomfortably like quarantine. We are left with Buzz Aldrin's question echoing across the darkness between worlds. Who put that there? And beneath that question, another one grows, more disturbing with each Mars mission that carefully avoids pointing its instruments at Phobos for more than cursory mapping. Why are we so carefully not looking? What are we afraid we might see if we look too closely? The monolith stands. It has stood there through all of human history, through the rise and fall of every civilization Earth has ever known. It stood there when we were painting caves in France, building pyramids in Egypt, reaching for the moon, and sending our first tentative machines to Mars. It stands there now, waiting. And perhaps, just perhaps, something stands there with it, watching to see if we ever develop the courage to come close enough to ask the right questions, to truly see what has been there all along, marking that doomed moon with a purpose we cannot yet understand. The question isn't just who put it there anymore. The question is whether they're still watching. And what it means that after all these years, all these missions, all this careful exploration, we still choose to look away. That's where this journey ends for tonight. If you made it all the way here, subscribe and hit the bell for more long-form stories like this. Check out the videos on screen for more right now. Drop your own experiences in the comments below. Thanks for listening, and I'll see you in the next one.